Hello viewers, welcome to Unacademy YouTube channel. Myself R.Vetrivel, Unacademy plus physics educator. Unacademy is the #1 online platform for coaching and teaching. The best plan for Karnataka CET 2021 aspirants. It is a comprehensive batch is live going on for complete syllabus coverage. So this pandemic period, this is the best option for all the aspirants, those who are looking for CET, NEET and JEE. Go for a trial price for 1 month plan or 6 month plan or 12 month subscription. Right? It is Unacademy affordable price, single subscription for unlimited access. So use my code VETRILIVE to subscribe Unacademy and you will secure the good rank in all the competitive examination. So today myself VETRIVEL going to give you the insight of acceleration due to gravity and Newton's universal law of gravitation. So we are going to discuss today only this basic concept in gravitation chapter. Newton law of gravitation, that is universal law of gravitation. We all know, right? The force of attraction or repulsion between two masses, right, m1 m2, separated by the distance d. As we know this, the force of attraction or repulsion between the two masses is directly proportional to product of their masses and inversely proportional to square of the distance between them. If we write as an equation, you will get capital G m1 m2, the product of the two masses, and square of the distance between them. We know gravitational universal law, right? And then we know that what's the relation between acceleration due to gravity and universal gravitational constant. G, universal gravitational constant. Small g, acceleration due to gravity. Now what is the relation between small g and capital G? We know that capital G m by r square. Remember, the radius of the earth, or if you raise an object, right, mass m to a height h above the surface of the earth, right? Since the radius, the height is negligible when compared to radius of the earth, then total we can take it as a r only, right? So relation connecting acceleration due to gravity, small g, and universal gravitational constant, capital G, is small g equal to g m by r square. We know that time period of, right, satellite, remember, t equal 2 pi by omega, that we can write t pi, right, time period of the satellite, 2 pi root r by g, capital R, radius of the earth. Generally we know time period, right, 2 pi root L by g, right, for the string. And Kepler's law of planetary motion, we all know. Law of orbit, law of area, and law of periods. In that law of periods, keep in mind, the square of the time period is directly proportional to cube of the radius, right? This further we can write t proportional to r 3 by 2. Remember? So based on this simple concept, today I am going to present you the important problem which appeared in all the competitive examinations, similar model. Yes, Let us proceed to the first question. Here it is. A satellite of the Earth is revolving in a circular orbit with uniform speed v. If the gravitational force suddenly disappears, the satellite will, what happens? See that we know we are launching, right, satellite. The satellite of the Earth is revolving in a circular orbit with the uniform speed. Okay. If the gravitational force suddenly disappears, we know that the gravitational force of attraction between the satellite and the Earth makes the satellite revolves around it. So if the gravitational force suddenly disappears, then what happens? See that option, continue to move with the velocity v along the original orbit. No. If the gravitational force disappears suddenly, it won't continue to move along the original orbit. Move with the velocity v tangentially to the original orbit. Falls down with the increasing velocity. No. Ultimately come to rest somewhere on the original orbit. No. The correct option is option B. Right? Moves with the velocity v tangentially to the original orbit. Generally, for a body moving in a circular motion, right, we know that whenever the body moves in a circular motion, right, whenever the body moves in a circular path, radius r, once you release it, right, suddenly it will move tangentially with the velocity. The same here. Whenever the necessary centripetal force provided right here by the gravitational force, so that makes it the satellite to move in a circular orbit. When gravitational force suddenly disappeared, then it moves with the velocity v tangentially to the original orbit. It moves tangentially to the original orbit. As usual, you will play, you tie the stone in the thread and overhead you will rotate. Suddenly you release it, it will go tangentially, right? It will not come in a circular path, right? So second option is the correct one. Yes, let us go for the next question. The reason of weightlessness in a satellite is, right? The reason for weightlessness in a satellite, we know this condition, when the lift is falling freely from certain height, you will feel weightlessness, right? In a satellite, weightlessness we will feel. What is the main reason? Inside the satellite, see, zero gravity, no, right? Center of mass is not a reason, none of this not a reason. See, zero reaction force by the satellite surface. Even the lift, right, weighing machine problem, when you are standing inside the lift on the weighing machine, right, we know that when the lift is moving upward, your weight, apparent weight is more than the real weight, right? When the lift is moving downward, it will be less. But whenever the lift is moving freely, when acceleration is equal to acceleration due to gravity, you will feel weightlessness even though you are standing on the weighing machine, right? Here, the reaction force, the total weight is acting vertically downward. The surface exerts the reaction force. That only here, right? Weightlessness, zero reaction force by the satellite surface, right? So that's why you will feel, the astronaut will feel weightlessness. There is no reaction force exerted by the satellite surface on the astronaut. That's why they will feel weightlessness. So no reaction force. See, we are able to walk on the surface. We just our leg, foot press the earth given the reaction force. That is why we can able to, same similar way, there is no reaction force there by satellite surface. That is why we feel weightlessness. So correct option C. Let us go for the next one. Two astronauts are floating in gravitational free space two astronauts are floating in a gravitational free space. There is no gravity. After having lost contact with their spaceship, the two will keep floating at the same distance between them, move towards each other, move away from each other, will become stationary. See that the two astronauts are floating in a gravitational free space because they lost their contact with the spaceship. Then the two astronauts, how they will move? See, in space, in space there is no external gravity, right? Keep in mind, the two astronauts are floating in a gravitational free space. In space, generally, see that in spacecraft, actually in space, external gravity is zero. There is no external gravity, right? External gravity is absent actually, right? So there is no external gravity, but there will be a very little small gravitational force between the two astronauts, right? The two astronauts consider as two different bodies, right? Two different mass. So even though in the space external gravity is absent, but there will be a small gravitational force between the astronaut. So that makes, due to which both will move towards each other with a very small acceleration. So both the astronauts will move towards each other with a very small acceleration. So option B is correct. Both astronauts will move towards each other with very small acceleration since external gravity is zero there. So these two astronauts, the gravitational force between them will act. Gravitational force is always attractive force. So these two astronauts move towards each other. Next question. The time period of a simple pendulum on a freely moving artificial satellite, right? The time period of a simple pendulum on a freely moving artificial satellite. So we know time period of the simple pendulum is 2 pi root L by G. Here you take it as a G dash, right? In artificial satellite, that is why I am taking G dash. In earth means G, take it. On artificial satellite, G dash to take it. Now in artificial satellite, what happened? Right, man-made artificial satellite. In artificial satellite, what is acceleration due to gravity? Zero, right? The time period of the simple pendulum on a freely moving artificial satellite, inside in artificial satellite, right? G dash, there is no acceleration due to gravity, is zero. So substitute now G dash is a 0. Now what happened? 1 by 0, infinity. So T become, time period become infinite. So option B is the correct one. Yes, let us go for the next one. If G is the acceleration due to gravity on the surface of the earth, its value at the height equal to double the radius of the earth, right? If small g is the acceleration due to gravity on the surface of the earth, its value at a height equal to twice the radius of the earth. We know relation between small g and capital G, right? Small g equal capital G m by r square. We know very well, right? It is on the surface of the earth now. Now see that its value, small g value at a height equal to double the radius. At a height, if you go certain height, radius will be twice given according to the problem. Now g dash equal g m by r square. What is r here? See, at height, see that from the surface of the earth, what is g value at a height equal to double the radius of the earth. at the height here, radius actually height, but it is double the radius of the earth at a height. So r plus 2r whole square. This is important now. So gm by 3r square. Right, you will get 1 by 9 gm by r square. Right, what is gm by r square? Right, small g. Gm by r square is small g. See here. So small g by 9. So g dash equal g by 9. So option D is the correct option. Right, at a height, its small g value double the radius of the earth is g by 9. Right, this is 9 denominator. Yes, let us go for the next question. The mass of diameter of a planet are twice those of Earth. Right, the period of oscillation of pendulum on this planet will be, if it is seconds pendulum on Earth, seconds pendulum means the time period of the pendulum is 2 seconds. Okay, see the question. The mass of diameter of a planet are twice those of Earth. Right, clearly understand. First, what is the gravity? We know gm by r square. Right, here the mass of diameter of the planet are twice those of Earth. Now, the period of oscillation of pendulum on this planet will be, so if it is C, acceleration due to gravity on the Earth by acceleration due to gravity on the planet equal, we know now how this equation, let's see how G and M, capital M, directly proportional. So mass of Earth by mass of planet into radius is C, radius is inversely proportional. So RT square by R square by R E square, radius of the Earth is radius of the planet. That's it. Now we know this relation, right? Now go ahead, G value on Earth by G value on the planet equal, right? So it is given clearly, see, the mass of diameter of planet are twice those of Earth. Right. So the mass of diameter of the planet are twice those of Earth. The time period of pendulum, right, oscillation of pendulum on this planet will be, right, here mass, right, remain constant, assume. So mass, you leave it, mass remain constant. Now how it is related? Small g and r, right, here rp, see, the mass of diameter of the planet are twice those of mass. So 2 by 1, this is, right. So moreover, now see that we know time period is inversely proportional to 1 by root g. Already we know time period of the simple pendulum 2 by root L by G. Now time period is, right, is proportional to 1 by root G. That's only here is given time period directly. Now go for on the time period Earth and planet. See here, question time period of oscillation of pendulum on this planet. So time period on the Earth by time period on the planet equal, we know it is inversely proportional to G, right? So G on planet by G value on Earth. That's it. So now what is given according to problem C? Right. Time period on the Earth will be, if it is seconds pendulum on the Earth, if it is seconds pendulum on the Earth, time period on seconds pendulum is 2 seconds. That is why bracket is given. If it is seconds pendulum, time period will be 2 seconds. So TE will be, right. So time period on the Earth is 2 seconds by time period on the planet we need to find, that is equal root 1 by C, GE by GP 2 by 1, GP by GE 1 by 2, reciprocal, write it. inside the root. That's it. So from this, D planet, time period of the pendulum in planet, find out. TP equal cross multiply, right? Root 2 into 2. So 2 root 2 second. So you know that option B is the correct option, right? Okay, let us go for next one. Here it is. A rubber ball is bounced on the floor of a room which has the ceiling at a height of 3.2 meter from the floor. The ball hits the floor with the speed 10 meter per second and rebounds vertically up. It goes up to the height, see the 3.2 total height ceiling. If all collisions simply reverse the velocity of the ball without changing its speed, then how long does it take the ball for a round trip, right? From the moment it bounces from the floor to the moment it returns back to it. Acceleration due to gravity small g is given 10. Question first understand what they are asking you. See that answer all in second. That means, right, how long does it take the ball for the round trip? Time period is the question. A rubber ball is bounced on the floor of a room, right, which has the ceiling at a height of 3.2 meter from the floor. Right, a rubber ball bounced on the floor. Height is given 3.2 meter. The ball hits the floor with the speed of 10 meter per second and rebounds vertically up. Right, how long does it take the ball to round trip? We know, right, in kinematics also you learned time period equal square root of 2h by g. That's it. Here clearly is given 2 into height. What is the ceiling height is given when the ball dropped on the floor, right? The ceiling at a height of 3.2 by g. G values 10. That's it. So 2 into 3.2 nearly 64, 6.4. So root 6.48. So 0. By 10. 0.8 second is the correct answer. Right? Time period is the question. If you understand the problem, very simple. Within 20 seconds you can do. Right? Okay. We'll go for the next problem. Two particles of mass m1, m2 approach each other due to mutual gravitational attraction. Right? Here one, this is m1. Right? It attractive force. Here you see, right, m2. Two masses. So we know according to law of gravitation, both attract each other, exert a force on each other, right? First one along the F1 force acceleration this direction, here A2 this direction, right? Along the force acceleration, two masses m1 m2 separated by distance d. See the question now, m1 m2 approach each other due to mutual gravitational force of attraction. Option 1. Acceleration of both the particles are equal. Acceleration of the particle of mass m1 proportional to m1 and then particle m1 proportional to m2. Acceleration of the particle m1 is inversely proportional to m1. Right? So question try to understand now. Right? So apply here when the two mass m1 m2 with the force, right, acceleration, what is the according to universal law of gravitation, force between these two mass m1 m2, capital G into m1 m2 by d square or r square, right? We know from here, see that F by m1 equal G into m2 by d square. What is F by m? F by m is acceleration. F by m1 here a1 acceleration. Acceleration now equal F by m acceleration gm2, right? gm2 by t square. See that? So gm square by d square. Now a is directly proportional to m, not m square, m2, right? A is proportional to second mass, right? m2. Now see the option C, right? Option C, you can see that acceleration of the particle of mass m1 is proportional to m2, right? See that m1 proportional to m2 because a by m1 is a1 acceleration. Is acceleration proportional to m2? Option C is correct one, right? Very simple, basic, if you understand. Now let us go for the next problem. The radius of the earth were shrink by 1% of its mass remaining the same. See that radius of the earth were shrink by decreases by 1%, its mass remaining same. Acceleration due to gravity on the earth surface would be, see that we know small g equal gm by r square. Now see here mass remains same, radius of the earth shrink by 1%. So if mass remains constant, that's only is given. If the mass remain constant, then how g is, mass is constant here, leave it, g also constant. So g inversely proportional to 1 by r square. Now percentage increase in g, see that percentage increase in g equal r square, right? When this earth is shrunk, completely original shape, if it is shrunk, what happen, right, on either side, understand, both sides it shrunk, so twice, right, percentage decrease in radius, because it's a radius, diameter means twice, so percentage decrease in r, that's only given. Radius of the earth shrunk by 1%, mass remains same. What is the acceleration due to gravity on the surface of the earth? So this is equal to 2 into, what is the percentage decrease in radius? Radius decreases by 1%, that's it. 2 into 1, 2%, percentage increase in g. So option C, C is the correct option. Yes, let us go for next one. A satellite is launched into a circular orbit of radius or around the earth. A second satellite is launched into an orbit of radius 1.01 r. The period of second satellite is larger than that of the first one approximately, right? Question, understand, this is a critical thinking needed. A satellite is launched into a circular orbit, right? Radius r is given around the earth. The second satellite is launched onto the orbit of radius 1.01 r. So here orbital radius is increased by how much? 1.01 means 1% it is increases, right? So orbital radius increased by 1%, right? What is the time period of the satellite? Time period of the satellite we know according to third law of Kepler, T proportional to R3 by 2, remember? So the percentage change in time period, we know that orbital radius here 1.01 time r mean 1% it is increases. So we know this Kepler's law, T square proportional to R cube, T proportional to R by 3 by 2. So percentage change in time period, right? The percentage change in time period equal, see, R 3 by 2. So first 3 by 2 will come. 3 by 2 into percentage change in orbital radius. Percentage change in orbital radius, either T proportional to R3 by 2, R power. So the time period is 3 by 2 time percentage change in orbital speed, that's it. So 3 by 2 into how much percentage changed? 1%. So 3 by 2, 1.5%. So option C is correct, 1.5%. Let us go for the next question. If the mass of the sun were 10 times smaller, see that mass of the sun were 10 times smaller and universal gravitational constant capital G were 10 times larger, which of the following is not correct? See, mass of the sun ms dash equal, right, 1 by 10 times lesser than original mass of sun. Similarly, gravitational constant nu dash will be 10 times larger, 10 times like original G, right? This is the condition given. That's it. You can go now, right, on the earth equal G dash is a GME on the earth by R square. We know formula, small g equal GM by R square, all on the earth. So G dash is on the earth will be how much? 10 G. G dash will be 10 times G increases, right? Mass of the earth by R square. That's it. This equal to 10. What is GM by R square? Small g. That's it. Right? So keep that. The raindrop will fall faster. See that. Small g, gravitational acceleration due to gravity on the earth equal to 10 times original gravity. So the raindrop will fall faster, right? Walking on the ground would become very difficult. Raindrop will become very faster. So walking is very difficult. So time period of the simple pendulum here on the earth would decreases. So D is the correct option. Right? D is the correct option. Let us go for the next one. Force between two objects equal masses F. If 25% of the mass of one object is transferred to the other object, then new force would be, see, we know force between two masses, right? Capital G M1 M2 by R square, right? So here G by R square, right? How much both? First initially both are at full percent, right? 100% initially. So you will get G by that R square equal F by this 100 in the 100, right? 10,000. Keep it. But second case, what is given? First case, equal masses, full percentage. So I taken percentage fully. Now 25% of the mass of one object transferred to other object, right? Now 25% of M1 transfer mean it will become 125 1, which is accepting. So now F dash equal G by R into M1, which is losing will become 75, which is gaining 25% will become 125. So 125 into 75, M1 M2. So you will get, right, G by R square into 125 into 125, you will get 9375. This is F dash. That's all. Now F dash equal F by what is given? 10,000 into what is G by R square? Here, see that G by R square F by 10,000 I am substituting. Right? G by R square is F by 10,000 into 9375. Now 937 by 10,000, you will get 15 by 16 F. So F dash equal to 15 by 16 F is the correct option. Yes. Let us go next and the last one. The mass M divided into two parts. See, the mass M divided into two parts. One is xm, another part is 1 minus x into m. For given separation, right? For a given separation, the value of x for which gravitational attraction between the two pieces become maximum. If the gravitational attraction become maximum mean, condition is derivative of that force df by dx should be 0. So here m is divided into two parts, right? This is considered as a one mass, this is considered as another mass. Now according to Newton universal gravitational law, F proportional to m1 m2. m1 is xm into m2, 1 minus x into m, right? Now equal, what will get now? This is x multiply now inside, m multiply everything, you will get xm square, take it out, 1 minus x, you will get this, m multiply x all multiply, you will get this. Now maximum force is the question. So for maximum force, see here, for find the value of x for which gravitational attraction between the two pieces become maximum. So for maximum force, the condition is df by dx should be equal to 0. That's only this you need to understand. For maximum force, df by dx should be equal to 0, right? What is df by dx already given here, right? That is equal d by dx. What is the x given? xm square into 1 minus x. This multiply inside, right? You will get actually, right, d by dx, multiply this all, you will get xm square minus x square m square, you will get, you multiply inside. Now derivative, take it, differentiation, xm square with respect to x, right, d by dx. So you will get only m square minus x square m square. X square will become 2x into m square. That's it. Now go ahead, now both side, right, this is equal to 0 because for maximum force df by dx equal to 0. Make it equal to 0. That's all. You find out now. M square into 1 minus 2x equal to 0. 1 minus 2x equal to 0. X equal to 1 by 2. So the correct option is A. Right. So the maximum force, right, will attain 1 by 2 option, right? So far we discussed today the gravitation, mainly relation between acceleration due to gravity and, right, Kepler's law based on. So champion batch is in progress. Learn from the best educator of Karnataka common entrance examination, right? Complete syllabus coverage, tips and tricks, save time to score better in exam. Have a try 1 month plan. Use my code Vetrivel. It is already in the descriptive box. So use my code Vetrivel to subscribe Unacademy, right? So I hope today we learned the basic concept of gravitation involving Newton universal gravitational law and relation connecting small g and capital G, right? We will meet again the next YouTube class with another concept of, right, important topic. Till then, myself Vetrivel, Unacademy Plus Educator, signing off from you all. Have a nice day. Thank you.